Assalamualaikum and hello, my name is Abang Muhaimin from group CS1103D, and today I am going to present about my design project application for ICT200. Firstly, we are going to be looking at the members of the group, and we have Sharifah, Nur'Aneefa, Aniza, Binti, Mohamad, and she is the group leader. And for the second group member, we have Abang Muhaimin bin Abang Muhammad, and that is myself. Now we are going to be looking at the background of the organization. We have Maria as the founder of Dot Waffles and its current owner. It was previously known as Waffleicious in the year of 2019. They specialize in dessert with homemade ice cream on top of waffles and toppings. Unfortunately, it was forced to a stop in the year of 2020 due to the worsening of COVID-19. This is the organizational chart of the business and its current system. As for the organizational chart, we have configuration manager at the top of the hierarchy, followed by database designer alongside with the programmer. For the current system, the flowchart starts by getting the customer's order. Once that is done, the order's availability will be checked. If the order is unavailable, then the customer will be notified. However, if it is available, then the customer will be given choices to pick from. They are given a choice to cancel their order, but if they wish to proceed, then they may make their payment. Moving on to the problem statement. First of all, they are still using the pen and paper method. It is very inefficient because the paper may go missing, resulting in the customers not receiving their orders. The second issue is data redundancy. When data is kept in multiple locations, it is very unlikely to be updated, thus making it difficult to manage. Finally, we have insecure data. There is a chance of losing data when all of it is stored in a single book. Next, we have a diagram that shows entity relationship, and it is called entity relationship diagram, or most commonly known as ERD. As you can see from the diagram, it shows one shop with its relationship based on the business rules that have been created. The primary key for employee is EMP_ID because it is labeled at the side with PK, and that is a short form for primary key. And for its foreign keys, there are EMP_first name, and then EMP_last name, and also EMP contact num, and everything that is labeled with FK at the side under the employee primary key. And the rest is just the same thing, but it's a different primary key under the same shop. Finally, for me, we are going to be looking at relational schema of the database. It has three forms, which is one normal form or 1NF, and it has single valued attributes. All of the columns in a table should have unique names to themselves. After 1NF, we have 2NF, or two normal form. It is based on the concept of dependency. For example, shop_position, shop_bonus, and shop_branch is dependent on shop_ID. It is the same for EMP_ID, CUS_ID, orders_ID, waffle_code, at underscore ons underscore code, payment underscore ID, and invoice underscore code. Every primary keys have their own foreign keys or attributes. Lastly, we have 3NF or 3 normal form. It is used to reduce data duplication. For the shop table, shop underscore ID is the primary key with its attributes such as shop underscore position, shop underscore bonus, and shop underscore branch. It is the same cycle for the other two primary keys tables. Employee and customer have their own attributes.
Hi, my name is Sharifah Nur'Aneefa. I will continue with the database implementation in my SQL workbench. To start, I will show how I created my database. I use command create database followed with the database name .toWayFalse. To make sure the database is created, we use .wayFall to ensure databases. You can see our database appear in the table. Next, we create table statement for all table structure. First of all, we create shop table. The attribute shop ID as integer data type, shop position as varchar, shop bonus in decimal data type with 2 decimal places, and shop branch as varchar. The primary key is the shop ID as it has a unique value. Select all from shop to show the table output. Bear in mind that we haven't inserted any data values, that is why the table is null. Continue with the employee table. We create table employee and define each attribute with its data type. We determine the employee ID as primary key and employee department number as foreign key that references to shop ID from shop table. We select all from employee and execute. This is the employee table that we have created. For the rest of the table, I will just copy paste here. These are the table of each entity. We have the database, .toWayFalse, we have shop table, we have employee table, customer table, orders table, wayfall table, add-on table, payment table, and we have invoice table. Refresh and hear all the detail in our database. This is the final table after we inserting some value in the table. Our group have made 7 records in add-on table, customer table, 12 records in employee table, 7 records in invoice, orders, payment table, shop table with 12 records, and wayfall table with 7 records. After that, move on to MySQL queries that including simple SQL queries, retrieve data from multiple tables, column function and grouping, and subqueries. I'm going to give one example for each queries. Firstly, we have simple SQL queries which divided into 3 comparison operators which equals more than or less than. We have logical operators and, or, and not, and special operators that we have between distinct and like. For example, comparison operators. The SQL script statement will return a list from the employee table with a condition, where employee at level must be greater than or equal to 16, and the list sorted by the employee at level. Second example, in logical operators. The SQL script statement will return a list from the shop table with a condition where shop ID must be less than or equal to 1104 or employee job position in shop is equal to manager. The list is sorted by shop ID. Third example for special operators using distinct clause. The SQL script select statement return a listing of different syrup distribution from the add-ons table, and the list is sorted by the syrup. Secondly, we retrieving data from multiple tables. Using join keyword, the select statement display employee ID, last name, employee in charge, and customer last name from employee and customer table, which employee ID refers to employee in charge, and with a condition where employee last name must be hash. For the third SQL queries, column function and grouping. The SQL script will use to retrieve and display the record of add-on code, fruit, and count, which count the number of fruit from the add-on table, where the list is grouped by fruit and sorted by add-on code. Last but not least, subqueries using where clause. The select statement returns employee ID, last name, hire date, and at level from the employee table. Using subquery with a basic predicate where, the list will return with a condition where at level of the employee is the lowest among employees. I think that's the end of my project demonstration. That's all for our group database presentation today. Thank you.